The James Webb Space Telescope has made stunning discoveries that are turning our understanding of the universe on its head since its launch in July 2022. Now, it's coming across a structure that, according to previous theories, should not exist, calling into question the entire Big Bang theory. Revisiting the universe's birth. To comprehend the early universe, we must journey back to a point where the concepts of time and space as we presently understand them had not yet taken shape. According to the Big Bang theory, everything existed in a state of perfect equilibrium. When observed through our physical measuring methods, this state appears as an almost inconceivable void. With a slight shift, the universe emerged from a solitary starting point. Picture this point as minuscule, even smaller than any point visible to the naked eye, yet simultaneously representing all the points that will ever exist in an instant. Cosmic inflation ignited with the Big Bang, causing the entire universe to rapidly expand from a subatomic scale to that of a golf ball. Whether space itself came into being at this moment or pre-existed remains an open question. During the initial phase of inflation, which saw a staggering 90-fold expansion, the cosmos grew exponentially. Within a fraction of a second, it transformed from subatomic dimensions to the size of a golf ball. Subsequently, the universe's expansion continued over time. It gradually cooled, albeit still remaining too hot for around 400,000 years to allow the formation of matter or light. The era of light's emergence is believed to have lasted over 500 million years. Initially, stars formed, some scattered individually across the universe, while others coalesced into chaotic star clusters. Highly organized galaxy structures, such as spirals or disks, are thought to have emerged approximately 1 billion years or even later. However, recent findings from the James Webb Space Telescope have challenged these long-held notions. It has identified at least 6 galaxies that had fully developed a mere 500 million years after the Big Bang, a perplexing scientific enigma. Among them, researchers from the University of Minnesota stumbled upon a diminutive galaxy that birthed an astonishing number of new stars relative to its size. Although this galaxy's volume is only about 1/millionth that of the Milky Way, it produced a comparable number of stars annually. During the era when its emitted light reached us, the other 5 galaxies exhibited unexpected features, painting a strikingly different portrait of the early cosmos. Studying these early galaxies holds the promise of unveiling the mysteries surrounding the timing and genesis of the first stars and galaxies after the universe's dark age. Consequently, questions are arising about whether the period slightly over 13 billion years ago truly represents the universe's birth, or if we must contemplate a complete reassessment of the universe's age. A sharper gaze with unprecedented clarity. When the James Webb Space Telescope, often referred to as JWST, was launched, it was evident to scientists worldwide that this cutting-edge technology would usher in an entirely fresh perspective on the cosmos. This was precisely the objective behind NASA, the Canadian Space Agency, and the European ESA collectively investing around $1 billion. Following more than 2 decades of revelations from the Hubble Space Telescope, the successor telescope aimed to delve even deeper into the cosmos. James Webb's observational range spans at least 13.5 billion years. Consequently, it may not peer significantly farther into space than its forerunner Hubble did. However, Webb boasts a remarkable advantage, a sharper view. Researchers can examine objects situated billions of light-years away, relying on subtle shifts in their light emissions or the phenomenon known as redshift. The greater the clarity of the images, the more precise the results yielded from their analyses. Naturally, astronomers eagerly anticipated using this new telescope to unravel the mysteries surrounding the stars and galaxies that existed shortly after the birth of the universe. Investigating these early stars and galaxies stands as one of the central objectives of the JWST mission. The oldest known black hole and early galaxies. Scientists have achieved yet another remarkable feat with the James Webb Telescope, uncovering a structure that might be the oldest known black hole in the universe. Thanks to the telescope's ultra-high-powered sensors, they've detected the telltale signs of a black hole's presence for the first time, approximately 570 million years after what was previously believed to be the Big Bang. Black holes are the remnants of long-deceased stars. What makes this discovery even more captivating is that it's a supermassive black hole, implying that multiple black holes might have merged over time, or it could have formed from the explosion of an exceptionally massive star. However, the mystery deepens when we consider that if these events occurred just 570 million years after the Big Bang, the stars that gave rise to this black hole must have been much older. Current astronomical knowledge indicates that the earliest stars likely had relatively short lifespans, with blue supergiants possibly burning out within a few 100,000 or million years. Yet this doesn't quite explain the existence of such a massive black hole so early in the universe's history. Additionally, the discovery of 6 highly structured galaxies at the alleged dawn of time adds another layer of complexity. The formation of galaxies of this magnitude is a time-consuming process. Our own Milky Way likely began as a mere collection of stars, then gradually evolved into clusters, some of which exploded and formed black holes. These black holes merged and grew larger, eventually exerting their gravitational pull on nearby stars, shaping them into the familiar disk or spiral structures we associate with galaxies. This transformation spans billions of years. The questions of how these black holes in the cosmic twilight could attain such immense sizes in such a brief time frame, and how fully developed galaxies emerged 200 or 300 million years after the Big Bang, will undoubtedly occupy scientists' minds for years to come. The enigma of CEERS 1019. CEERS 1019 had already made its debut in Hubble data when a team of scientists embarked on a quest to unearth the oldest traces of star formation, often referred to as the first light or Lyman alpha emission in scientific circles. This type of radiation arises from the ionization of neutral hydrogen. According to previous theories, the early universe was shrouded in a nebula of neutral hydrogen, hindering the free propagation of light. Only after this hydrogen underwent ionization could light traverse without hindrance. The process of reionization remains a perplexing enigma in the realm of science, and it's possible that it might not have occurred at all. It's conceivable that much of what researchers had assumed up to this point could be flawed. The James Webb Space Telescope, JWST, armed with its immensely potent infrared instrument, scrutinized CEERS 1019 and the supermassive black hole in this ancient galaxy far more closely than the Hubble. Once again, scientists were in for a surprise. Galaxies of this vintage typically emit light stemming solely from early star formation. However, this particular galaxy exhibited evidence of both star formation and a black hole. While black holes themselves don't emit light, they possess a unique way of gathering matter, which then emits radiation. CEERS 1019 displayed both types of light emissions, a circumstance that defied conventional understanding. Consequently, researchers now find themselves grappling with more puzzles and mysteries than ever before. For numerous fields within astronomy and cosmology, these revelations entail re-evaluating decades of work, recalibrating theses, and rewriting textbooks. The ongoing debate over the Big Bang Theory. While many astronomers and space enthusiasts are convinced that these remarkable discoveries have debunked the Big Bang Theory, the world of science remains cautious about such declarations. For nearly a century, the Big Bang Theory has presented a cohesive framework, with supporting evidence like the expansion of the universe and data from cosmic background radiation seeming to affirm this hypothesis. Researchers are not yet prepared to discard the Big Bang Theory entirely. It's conceivable that the universe's birth may have occurred much earlier, extending its age to 15 or even 20 billion years. Alternatively, the universe could operate differently in its early stages than previously assumed, cooling down more rapidly and giving rise to stars, galaxies, and black holes much earlier than expected. Currently, scientific teams worldwide are diligently working to reconcile these new findings with established theories. Whether they can harmonize the new data with the old theories or whether the JWST will ultimately challenge the Big Bang Theory remains a question that will be answered in the coming months or possibly years.